Happy day, this is Dr. R. JAMUNA CHEZHIAN, Assistant Professor, Department of Mathematics, M.O.P. Vaishnav College for Women. So today I am going to introduce discrete mathematics and discuss its applications. Discrete mathematics is a study of mathematical structures that are countable or otherwise distinct, like integers, graphs and statements in logic. It is a foundation for many essential areas of computer science, AI, data science and engineering. It helps us to solve problems and build technology. Some of the core topics in discrete mathematics includes logic, set theory, number theory, combinatorics, recurrence relations, mathematical induction, graph theory and algebra. In computer science and AI, discrete mathematics is used in creating algorithms and its analysis. On recurrence relation, graph theory and combinatorics plays a major role here. It is also used in optimizing the data storage and its retrieval. We use set theory and Boolean algebra for this purpose. Also, it enables secure data communication, for which number theory plays a key role. Also, discrete mathematics plays a major role in modeling computation in finite state machines and compilers. And again, set theory, Boolean algebra, combinatorics are some of the topics which are used in this field. In engineering, discrete mathematics is used in coding theory for error detection and correction during data transmission. It is also used in optimal resource scheduling and for modeling communication and transportation networks for performance, and also it is used for digital controls in control system. Coming to data science, discrete mathematics is used in data modeling and representation, statistical analysis and sampling, pattern recognition and network analysis, logical reasoning and in taking rule based decisions. Now let us see the application of recurrence relation in generation of pseudo-random numbers. Recurrence relations are relations used to define a sequence where each term of the sequence is represented by its previous term or many of the previous terms. And pseudo-random numbers are numbers which are generated algorithmically but appear to be statistically random. They have seed based reproducibility, and some of the areas in which we apply pseudo-random numbers are in simulations for modeling complex systems in science and engineering. We apply pseudo-random numbers in cryptography for securing data with unpredictable keys. It is also used in gaming in generation of random game events and its outcomes, and in statistical sampling where it enables unbiased sample selection for analysis. So one of the simplest, efficient and widely used algorithm for generating the pseudo-random numbers is a linear congruential generator, which uses the formula xn plus 1 is equal to a into xn plus c into mod m, where a is the multiplier, c is the increment and m we call it as a modulus. So for generating the pseudo-random numbers with this algorithm, we choose an initial value x0 which we call it as a seed. When we look at this formula, we can see that xn plus 1 depends upon xn, which implies that it is a recurrence relation of first order, and xn plus 1 is a remainder when a into xn plus c is divided by m. Now let us see how this algorithm works by choosing or fixing values for the constants. So I have taken a to be equal to the number 1664525 and c to be the number 10139042223, m to be equal to 2 power 32, and I have taken x0 the seed value to be equal to 42. So all these values are chosen in order to ensure a long period and good randomness. So by applying these constant values in the formula, we will be able to generate the random numbers, and here we can see the first few random numbers which are generated using this algorithm. So as we can see, x1, x2, x3, all these numbers seem to be completely different and they are random without following any particular pattern, although they are generated by using a formula. Pseudo-random numbers are widely used in games because of its unpredictability nature, because of its fairness and simulation and training. Now consider the classic game of rock, paper and scissors, where each player can choose either rock, paper or scissors with certain probabilities. Suppose a player A uses a mixed strategy where he can choose each option with equal probabilities. Then to stimulate players A strategy, we need to generate a pseudo random number in the interval 0 to 1. depending upon the number, whether it lies in the interval 0 to 1 by 3, or it lies in the interval 1 by 3 to 2 by 3, or in the interval 2 by 3 to 1, we can decide whether the player will be choosing rock, paper or scissor. This situation is completely predictable and fairness, but for the players who are playing along with the player A, it seems like he is doing it in a random fashion. So, this is a very simple and beautiful application of discrete mathematics which depicts the importance of discrete mathematics. Thank you.